So chapter 4 example with linear regression, it says we're in Tolson Lake and it's a Canadian Northwest Territory. This lake has many northern pike. The following data was obtained by 2 fishermen visiting the lake. Let X represent the length of a northern pike in inches and let Y represent it in pounds. First, section 1 of chapter 4 has a straw scatter diagram. It says using the scatter diagram, no calculations whatsoever, would we estimate the linear correlation to be positive, close to 0, or negative, and explain your answer. So the first thing we have to do, guys, is we have to graph it. Try to pick a scale that's kind of normal. So do you guys notice with our X, the very first thing we have is 20? Like, I don't want to do 0 through 20. I want to jump right to 20. So anytime you want to do that, you kind of do like this lightning bolt or this heartbeat that shows like you took a chunk out of your x-axis. Have you guys seen that before? It just shows that you've taken a chunk out of your x-axis. You're not starting right at 0. So let's just count maybe by 2s. 20, 22, 24. We might have gone too small, but that's okay. I'll extend my line. It's no big deal. So this is length in inches. So I counted by 2s. If you wanted to count by 4s maybe, just make it fit better, it's totally up to you. What's nice about MyMathLab is they'll have the graph already for you. You just have to make sure you pick the appropriate graph with the right axes labeled and so forth. Looking at the y-axis, notice the y-axis starts pretty low at 2, so I'm actually going to start at 2 and just jump up by 2s, okay? So this is 2, 4. And we'll label that, guys, that is the weight in pounds. And we'll just do northern pike for our graph name. When it comes to doing your scatter diagram, your calculator actually does scatter diagrams for you. But I think it is longer and it's harder to figure out than just plotting the points themselves, okay? So this data that they gave us, when a fish was 20 inches long, it weighed 2 pounds, you're just plotting that point, 20, 2. So we would just go to 20, 2, and that would be the first fish. The second fish was 24 inches long and it weighed 4 pounds. So you go over to 24 and you'd go up to 4. The second fish was 36 inches long and it weighed 12 pounds. So go over to 36 and then go up to 12. 41, you got to eyeball it kind of halfway between 40 and 42. You're going up to 15, halfway between 14 and 16. And last but not least, 46 is all the way up here at 20. Okay? So honestly, it looks almost like a straight line except for that 41 looks like it dipped a little bit. So looking at our scatter diagram, we need to answer the question. Is this positive, close to 0, or negative? It's positive, and is it close to 1, 0, 1 or 0? Yeah, I'd say it's positive, close to 1. So I'd say it's strong, right? Notice we were able to do all that without any calculating. We just plotted the points, and once we plotted the points, we just looked at the line. It's positive because as one moves up, so does the other. It's close to 1 because it's a pretty good line, so that gives us a strong relationship there. All right? The next thing that we have to make sure we feel comfortable with when it asks us questions, guys, is it wants us, for the given data, to write the equation of the least squares regression line. So that's when we have to put it in our calculator and come up with the y hat equals ax plus b. Okay? So in your calculator, I don't know if you can see that, we're going to go to Stat, Edit. I'm going to clear out my list. You guys clear out yours. And in list 1, we're going to put our inches, 20, 24, 36, 41, 46. And in list 2, go ahead and put your weight in pounds. And then we're going to go to Stat, Calc 4, Lin Reg. You can't really see that, can you? There you can see it a little bit, okay? My math lab will do a better job than these worksheets do when it says what to round to. Let's round to like 2 decimals, okay? So we will write this as y hat equals 0.68x minus 12.03. Does everybody see where that comes from? Your A is always your slope, so this was 0.6775, so we're rounding to 2 decimals, it's just 0.68. And then your B, I know that the glare is kind of bad, I'm sorry. The B is negative 12.03. So it's y hat equals 0.68x minus 12.03. Guys, we're not going to worry about graphing the line because our scale is kind of weird. We can't even dip into the negative, so we won't worry about that for now. All I say for a hint on my math lab is pick line with correct axes, plots, and y-intercepts, okay? Because what they're going to do is they're going to give you 4 lines. 2 of them are going to have the axes flip-flop. So right off the bat, you're going to be able to rule out 2. And the other ones, I think either the y-intercept's wrong on the line or the dots are wrong, okay? So here we want to pick the line that's crossing at negative 12 and go from there. So we're not going to worry about part B, but we're going to pick the line with the correct axes, the right dots, and the correct y-intercept. On number 3, I know it's kind of hard. I'm going to turn this back off. I think it's easier to read it without that. On number 3, they're going to ask for the correlation coefficient R and the coefficient of determination R squared and give a brief explanation of both. Let's just focus on R. You guys can see here, R was 0.9962. So your correlation coefficient R equals 0.9962, like that. What does that mean in words? Well, it should tell you 2 things. It should tell you what direction, positive or negative, and it should tell you strength, strong, moderate, or weak. So is it positive or negative? Positive, strong, moderate, or weak? Strong, okay? So this is a strong, positive, linear relationship. Strong, positive, linear relationship. So direction and strength. Strong, moderate, or weak. And then direction, positive or negative. So basically that means that it's very, very explanatory, meaning the length of your fish really does explain how much it weighs. All right? The coefficient of determination is r squared, or little r squared, it doesn't matter. It's 0.9924. Does that look right? Is that what you guys have for your r squared in your calculator? What does that mean in terms? That's what I had you guys quote on your notes. What we're going to do is we're going to change this to a percent. So it's going to be 99.24%. My lead always wants to run away. 99.24% of the total variation in weight is explained by the least squares regression line. So remember, the percent will change and your y variable will change. So in this case, our percent was 99.24%, and then our y variable was the weight. So 99.24% of the total variation in weight is explained by the least squares regression line. Or you could say pounds, because that doesn't really say weight up in our data, it just says pounds. That means there's almost 100% correlation, 1-to-1 correlation with height and weight. On humans, it wouldn't be that perfect, right? Like, there's a lot more that goes into our weight other than just our height, our bone density, our muscle mass, and so forth. But fish, or at least specifically northern pike, not too big of a difference there, all right? If you get that, go ahead and flip it over to the top of the second page. On the top of the second page, we see the word predict. It says, if a 32-inch northern pike is caught, what is the weight in pounds predicted by the least squares regression line? If you see the word predict, that means plug in. So what we're going to do is we're going to take our y hat from the previous page, and we're going to plug in 32. So say we're out fishing, and for some reason we don't have a scale, but we have our graphing calculator. We are able to weigh our fish, because you have to throw them back if they're a certain size, right? So we don't have a scale, but we have a graphing calculator, so we can come up with this equation, and we can plug in our length and get an idea of how much this fish weighs, all right? So predict always means plug in. You want me writing up there where you can't see it? That's really helpful. Thank you. Predicting means plug in. So we're going to use y hat for the 32-inch, or we're going to do y hat equals, what was it, 0.68, yep, and then minus, was it 12.03, okay? So what is our x? Our x was the length in inches, so I plugged in 32 for my x. Just shove that in your calculator just like that, 0.68 times 32 minus 12.03, and we'll get a rough idea of how much this fish weighs, 9.73 pounds, okay? So say anything under 10 pounds you have to throw back. So we'd have to throw back this fish, all right? It asks us to do the exact same thing for a 55-inch northern pike. The only difference is we're going to plug in 55 now for our x instead of 32. So we'll have y hat equals 0.68, but now our weight, or excuse me, our length is 55 inches. So throw that in your calculator, 0.68 times 55. Minus 12.03. Is that 25.37 what you guys get? I kind of want to talk about these two. There's two terms I don't think the book uses specifically, but it's interpolating and extrapolating. Just like interstate, or, you know, like kind of, interpolating means it's okay to use it. For example, if you look at 32 inches, he kind of falls in the range of the fish we caught, right? So this line that we came up with, using it to predict the weight of a 32-inch fish makes sense. But what do you notice about this guy? 55 is kind of off the chart, and so we might not use this specific equation for a 55-inch because at a certain point, maybe the correspondence isn't as perfect. Maybe at a certain point, like, they don't gain as much weight, okay? So we probably wouldn't use it to predict it. Don't use it on this line. Don't use on 55 inches. And you can say outside of range or something like that. You guys, does that make sense? You see what I'm talking about? A 55-inch fish is nowhere close to the ones we caught because we based our line off of this data. And none of these are close to 55 inches. So if we're using this data to use predictions, we would maybe want some bigger fish and make a new chart and a new line using fish that are a little bit larger. 32 falls right in here. Notice 32 is right in between here, and our answer was 9 point something. It falls right between 4 and 12. It works perfectly. But this one you wouldn't probably use for a 55-inch northern pike because we're kind of outside of that range. All right, last one, the sum of the squared residuals. Sum of the squared residuals. Add that word in. So this is like on 4.2. I really think you see it real quick, like number 2 and 3 of your homework. And you actually have to do it twice, okay? The first time they ask you to do it in that problem, you do it with a made-up line. And the second time you do it, you use it for the squared residual line, all right? What we're going to do is we're going to write everything we want to do in our calculator on here so we can refer back to it. Then we'll go do it in our calculator, okay? So list 1 does not change. What's already in list 1? Our x values, right? So that's just your x values. So our lists are going to do all the work for us, guys. What's already in our list 2? Our y values. All right. What is our goal? Our goal is to get the residuals. And if you remember, our residuals were that error between observed minus predicted. We have our observed. What we don't have is our predicted. So that's what our list 3 is going to be. Our list 3 is going to be our predicted. So what I'm going to say is highlight list 3. Type equation of line using L1 for x. And I'll make all that make sense in a second, okay? So what we're going to do is, instead of doing this point by point, each of the 5 little fishies, and finding their predicted ones one at a time like we did in number 4, our list can actually do all 5 at once, okay? What we're going to do is we're going to tell the list what our line is. The list is going to plug in all of our x values, but where are x values listed? In list 1, okay? So we're basically saying in the equation, instead of x, put all the values in list 1. Right there we have our predicted values, all right? In list 4, we want our residuals. I just want to remind you what your residuals are. They are the observed minus predicted. And I know that seems kind of foreign to you if you haven't been working on the homework, but the observed values are what actually happened. That's list 2. So we're going to highlight list 4 and type list 2 minus list 3. Because our observed values are in list 2, our predicted values are in list 3. Okay? So we're going to just tell it to take everything in list 2, subtract everything in list 3, and we'll have a column of all of our errors, all of our residuals, all right? It'd be nice if we could just add up that column, but negatives would cancel out with positives. So what do we have to do? We have to square them. That's why it's called the sum of the squared residuals. So list 5 are the residuals squared. So guess what we're going to do? We're going to highlight list 5, but we're going to square list 4. Okay? We're going to highlight list 5 and in there type list 4 squared. I don't know why I raised it to the 5th power. I got really excited there. Sorry. Just square it. Don't raise it to the 5th power there. So guys, this is kind of your cheat sheet. You do not have to do this on the test. This is not on the test. Why am I the mean teacher that has you do it a couple times in your homework? Because I like you to see why that least squares regression line is the best line. In the 2 problems you have to do it in your homework, you'll do it with a fake line, and you'll do it with the least squares regression line, and the least squares regression line always has the smallest sum. Okay, so let's go ahead and do this in our calculator. Let's see if what I had as right makes enough sense that you can go repeat it. Okay, so guess what we already have in our list? We already have our links in list 1. We already have our y values in list 2. But in list 3, what did I tell us to do? I said go highlight list 3. When I mean highlight list 3, arrow up and be in list 3. Do you see how list 3 is highlighted right there? Okay. In list 3, when you start typing, it actually shows up down here. Okay. What we're going to do is we're going to type that least squares regression line. You can kind of see it right in number 4, right? What do we have? We have 0.68. And we want the x's there, correct? But where are all of our x's located? In list 1. So what we're going to do is we're going to hit second 1. So hit second 1. So basically, here's our 0.68x, because all of our x's are here, right? And then we still have to subtract, so minus, was it 12.03? And you hit enter. You should get a list filled with values close to L2, but not exactly, right? And so that first fish should weigh about 1.6 pounds, but ours actually weighed 2 pounds. The second fish should weigh about 4.3, but ours actually weighed 4. So this is all the predicted values, and all they did was what we did in number 4, but they did it 5 times all at once, okay? So we want our residuals, so we want to take our observed minus our predicted, so we're going to go over to list 4. I'm going to clear out my list 4 because I have stuff in there. And you highlight list 4, and you say, hey, list 4, I want you to take my values in list 2 and subtract my values in list 3. So I'm just going to do second 2 to get list 2 on there, minus second 3 and you hit enter. And you should have a bunch of small values because that's the whole idea. It's a residual, so it's our error, but we used our least squares regression line, so we want it to be pretty small. So what we have going on is all of them are rather small because all the values in list 3 were pretty close to list 2. But some are positive and some are negative. That just means some of the fish weighed more than they're supposed to or weighed less than they were supposed to. And then if you're not getting it, I can help you like when we're working on our worksheet. It's not a big deal. All right, the last one is list 5. Clear out list 5 if you haven't already. And what we want is we want to square list 4. So we're going to go highlight list 5. But we say second 4, so there's list 4. And then, guys, your square button's right here, just right next to the comma. And you can't really see my calculator when I do that. And you hit enter. So what it did was just took each of those really small decimals and squared them. All right, so at this point, guys, we have the squared residuals. We just don't have the sum. So since there's only 5 things, could you write them down and then go back and add them up? Sure. But guess what your calculator does? It sums it, all right? So let's again write down the directions, and then we'll do it in our calculator in a second. So to sum, we're going to hit second stat. I know you can't see with that. Second stat, which is technically your list feature. Scroll to math. And I forget what it is. It's number 5, sum. Scroll down to number 5, sum. My M looks really scary, but you know that's an M, okay? So we're going to hit second stat, which is technically the list feature, and it tells you everything you can do with your list. So we want to do math with our list, so we're going to scroll over to math, and what math do we want it to do? We want it to sum it. So on your main screen, sum is going to pop up like that. And it's just sitting there waiting, saying, what list are you wanting me to sum? Well, where are our squared residuals? They're all the way in list 5. So you just type in list 5 right there and hit enter. And it will sum it for you. So second stat is the list feature. So go ahead and do that, second stat. Scroll over to math. And then hit 5 or scroll down to 5. And it should pop up sum on your main page. And when you sum list 5, I think it's pretty small. What do we get for our sum? It's rather small.
1.75.
Yeah, it's not very big at all. So I'm going to hit second stat. And I'm going to scroll over to math and down to sum. And I want it to sum list 5, so I'm going to hit second 5. And you hit enter. That's unreal. You will not get them that small, just FYI, okay? That means once I took all those little gaps and squared and added them up, the sum of my squared residual was 1.7565. I can help you out, Jake, in a second, okay? And they're going to ask you, what does this mean? Just in a nutshell, guys, if you had any other line and you did all these steps with any other line, the sum would be bigger. Okay, any other line would give you a larger sum. Any other line would give a larger sum. So if Joe Schmo thought he had a better line to describe the weight of the northern pike, we would do all 5 steps with him in the list, and we would do this, and we might get 2.2. Okay, so his line was good. It wasn't as good as our least squares regression line.